So our formation of amide, peptide, formation of peptide, we have seen how this peptide linkage formed. Now dipeptide formed. That means we have two peptide groups. Now, if we want to form, let's say, tripeptide, how would that be? Like dipeptide means actually basically we have like a single peptide linkage. In this case, let's see, we have, let's say, this is a single peptide linkage, and let's say we have formation of tripeptide. Let's say we are taking the combination of aspartic acid, then we have cysteine, and we have lysine. So these are the combination. In this case, in this manner, we will be forming the reaction. So let's say the monomers or the initial components are the NH amine, and we have CH2 COOH, which is our aspartic acid, and we have our COOH. We also may them to react with this amine. So this is our this amine, and we made it to react with the third molecule, which is this amino acid. So this is an amino acid, this is another amino acid. This is our third amino acid. I'm just writing it as like short version, CH2 4, because writing CH2 4 times right now it takes too long, but I will urge you to write in your exam like the 4CH2, because you will write just once in your exam. So that could be done. Now, at first, the first molecule should be aspartic. So our aspartic acid, the amino acid where it contains the aspartic acid. So CH2COOH, and we have this C. So this is like, remember, only this is not the aspartic acid. Having this part as the R group in the whole amino acid known as what? This is known as now the aspartic acid. This is known as the glycine, and the top one is known as the, I forget his name, which is cysteine. Yeah, cysteine. Now, this is our carboxylic acid. This was our carboxylic acid, but it formed bond with a nitrogen. Just a minute, it's sort of hanged here. So NH, and we have CH2SN. We have this C double bond O, then we have the other part, NH, and CH2 CH2 and NH2, and we have this C double bond O H. Okay. Now we have this amide linkage, peptide linkage, and this peptide linkage. I keep on saying amide, but I'm sorry for that, but this is a peptide linkage. Okay. Now the portion I mentioned we'll be studying is zwitterion. Now, what is zwitterion? Let me give you a hint from these structures. Here we have what? COOH, and here we have NH2. NH2 is prone to what? it has a tendency to gain electron, isn't it? Because this is basic. So gaining a hydrogen, H plus, is its nature. However, carboxylic acid has a tendency to lose electron, lose a positive charge. That means it can donate a H plus. Here it can donate H plus, and here it can gain a H plus. That means what? After donating H plus, what will this form? COO minus, and this one will form what? NH3 plus. That forming of ions from this amino acid is known as your zwitterion, or the ions, or the, let's say, the substance which have both positive and negative ions are known as zwitterion. Now let's see. So ions which have both positive and negative ions called zwitterion, and they have an overall charge of 0. So overall, that means what? If we have plus 1 and if you have a minus 1, for example, amine will have NH2 will gain a hydrogen and become NH plus, and the C double, like carboxylic acid, will lose an electron, lose a hydrogen and form what? COO minus. A plus charge and a minus charge will eliminate each other and form what? Like a neutral charge. That's why overall charge of Zwitter ion is what? 0. Okay. Now let's say we have an example. So let's say we initially took the simple alanine. So this is, let's say, our structure. What will happen is this carboxylic acid will donate a hydrogen. That hydrogen will be gained by this amine, okay? Forming in, let's say, forming 3 bonds, so NH3 plus, and we have the rest of the molecule, C double bond O, O minus, okay? That is our zwitterion. So the plus and the minus charge cancel out each other. This is alanine, this is zwitterion. Okay. Moving on to our next part, let's say we have this zwitterion present, okay? Let's say we have this zwitterion present here with us. So let's take an example of the alanine. Let's say we have this alanine, alanine's zwitterion, which we just got. Now, if we, let's say, add with this zwitterion, two conditions. One is add H plus. Okay. Another is adding OH minus. What will happen? OH minus added. Okay. Now, if H plus is added, what will happen? Think it wisely. If you add H plus, what happens? We are making it more acidic. We are increasing the number of H plus. That means what? It becomes more acidic, and more acidic means what? pH value decreases. So pH value decrease. And OH minus adding means what? More alkaline. That means acidity will decrease and alkalinity will increase. Alkalinity increases means what? pH value increases. So pH value increases. Okay. Now let's say if we add H plus, that what will happen? When we add H plus, it will happen that the negative portion, or let's say the portion which was like this part, okay, so CH and we have CH3, that was like C double bond O minus, this portion will gain the hydrogen, forming OH. Now see what? We have overall charge of what? +1. In this case, a +1 charge. isn't it? Now, if we added OH minus, what would have happened? The opposite would have happened. This H plus, extra H plus, this will break the bond with amine and form a water neutralization reaction. So like simply a neutralization reaction will happen, and this CO minus will remain what it was. And that broken H plus with OH minus, it will form what? H2O. Okay, that will like be a side product, let's say. However, here is overall charge. We are getting what? Overall charge of -1. Okay, so that's our Zwitter's characteristics. Got it? So in our next lecture, we will see some examples, like the previous examples. So conditions will be given, molecule structures will be given. They will ask you to find what molecule, what will be the structure, that sort of thing. And we will have some detailed information and detailed, information about the proteins and the type of like attraction of like the structure of proteins, then the bonding types, what type of bond they can, like this sort of like amino acids or these polymers, the proteins can form between them. And yes, so yeah, we will be inshallah good to go. So that's all for today. Take care. Assalamu alaikum.